So just a reminder before we get started, you are watching a video right now, which means that you have a pause button. So if I go too fast, just pause the video. You also have a rewind button. So if you need to hear me explain something more than once, feel free to rewind the video and listen to me explain it again. So today we're working on section 4.3. We're still in one-step inequalities, but this time we're talking about multiplying and dividing. So I have two review problems for you here. So I would like you to pause the video now, try out these two problems, and once you're done, hit play again. And here's your two answers. So for the first one, it should have simplified to x is greater than 6. Remember, since it does not have the line underneath, we have an open circle here. To figure out which direction the arrow is going, we're going to test the number to the left and the number to the right in the original problem. So I plugged 5 into the original problem for x. 5 minus 2 is 3. 3 is greater than 4 is not a true statement. It is a false statement. So we have our one false. The other one should be true. So I took my 7 and I substituted it in for x. And then I said 7 minus 2 is 5. 5 is greater than 4 is a true statement, so our arrow is going in the true direction. I did the same thing for the second problem. It is basically the same problem, so I'm going to let you double check yourself. If you got it good, right, oh gosh, if you got it correct, good job. You're going to do well today. If you got it wrong, maybe pause the video now and go into our help session, and I will help you understand this a little bit better. Okay, so now we're going to do a flashback to chapter 3. So we are solving the following inequalities. So hopefully you remember how to solve these one-step equations. Sorry, these are equations. So I'm going to do the first one with you, and then I'm going to have you do the second one on your own. So just like before, we're drawing our line. We're circling our variable. And we're going to be solving for our variable. So I should get an x at the end. I'm asking myself what's happening between the 8 and the x. Since it's multiplication that I see, I'm going to do the inverse operation, which is division. So I'm dividing both sides by the number that's keeping x from being alone. So 8 is preventing x from being alone, so I'm dividing by 8 to get rid of it. Dividing on that left side as well by the same number that I said before. I'm copying that symbol down. So I'm making sure that I write the same symbol. 8 divided by 8 makes that go away, and we're left with just an x, which is actually what we want. Now we're going to do the same thing to the next side. We're going to take 48 divided by 8, and that should give us 6. Since we have a variable on one side and a number on the other, I know that this is my correct answer, or my simplified answer, I should say. I would make sure that it's correct by taking 8 and multiplying it by x, or 8 times 6. In my calculator, that is 48, so I know that I did it correctly. So try that next problem. Ask yourself what's happening between the x and the number, and solve for that x variable. And there's your answer for the second one. So we saw that it was division, so we know that we have to do multiplication. That's why I have my multiplication symbols out right there. And then I have to get rid of that -3, so I multiplied by -3, which makes that go away. On that right side, we're taking 12 times -3, which is going to be -36. So I want you to look at these two problems, and I want you to write down an oh my gosh, I can't talk today, sorry guys, an explanation on how to solve a single step multiplication or division equation. So these are both equations. This one's multiplication, this one's division. I want you to explain how to solve these problems. So pause the video, write out your explanation. So you could have said something like, we start off by drawing our line at our equal sign. We circle our variable. We simplify both sides. And then we're doing the inverse operation to the variable side. So the operation that's happening here is multiplication. The inverse operation is going to be division. And then once you have that, you have your answer. So we're talking about inequalities today, though. Most of the time, inequalities are the exact same process. We just copy down that inequality sign for the most part, and we'll get to some special cases. So, like I said, and like we did for equations, we're drawing our line, this time at the inequality sign instead of the equal sign. We're still going to circle our variable. If I had anything to simplify, I would simplify it. And then I'm doing the inverse operation to both sides. So since I see multiplication happening there, I'm going to do division on both of my sides. I need to get rid of that 4, so that's what I'm going to divide by. 4 divided by 4 is 1. 1 times n is n. On that right side, we have 24 divided by 4, which I know is 6. And then I'm going to copy down that same inequality sign. And that's what it is simplified. So let's go ahead and graph that solution. So I know that there's infinitely many numbers that it could be, so I need to represent this by using my number line or my graph. So I know 6 is going to go in the middle because that's the number that I got. I need one smaller than 6, and I need one bigger than 6. Next thing I'm going to do is I am going to draw my circle. So since it has the line underneath, I know it's going to be a closed circle at my number 6. And then my final step for graphing is to figure out which direction the arrow is going. So I need to draw my arrow in the direction of the true side. So I'm going to use my original equation, just like how we did in addition and subtraction. And our original inequality is 4 times n. So 4 times n is going to be 5 in this case. So 4 times 5 should be greater than or equal to 24. So let's simplify that. 4 times 5 is going to give me 20. Is 20 greater than or equal to 24? Hopefully you say no. And so this is our false side over here. So we should always have one true statement and one false statement. We've used our false, so we're going to hope that this is true, or else we did the problem wrong. So just like on that left side, I'm taking 4 times n. In this case, I'm using 7. So 4 times 7 is greater than or equal to 24. I know 4 times 7 is going to give me a 28. So now my question is 28 greater than or equal to 24? And I hope that you're saying that it is, so that is our true statement, which is good. It means that we did the problem correctly. And we're going to go ahead and draw our arrow in the true direction, which looks like that. So I've solved this problem. I want you to solve this problem now. So go ahead, pause the video, and try that problem. Just take note that this is division right here. So you're doing the inverse operation of division. Pause the video now. And here's your answer to double check yourself. So I saw division by 5. So I did the inverse operation, which is multiply by 5. And I did that on both sides. So since I divided by 5 and then multiplied by 5, those cancel each other out and we're left with our x. On the right side, we have 3 times 5, which is going to equal 15. And so this is going to be my simplified inequality or my solved inequality. Now we have to go ahead and graph it. So I know that 15 goes in the middle, one less is 14, one more is 16, and I took those numbers and I substituted them in for my x up there. So 14 divided by 5 is less than 3 as my first one that I'm testing. In my calculator, I typed 14 divided by 5 and I got 2.8. 2.8 I know is less than 3 because it's 2 and something instead of it just equaling 3. So that's going to be our true statement, which means this should have been our false statement, and it was, because 16 divided by 5 equals 3.2, which is actually more than 3. And then this was our final graph. So it is an open circle because there's no line, and the arrow is going left because that's simplified to a true statement. So if you look at both of these, you might realize that these are both positive numbers that we're multiplying or dividing by. I didn't give you any negatives in this case. So let's see if it holds true with negative numbers. So I want you to multiply both sides by a positive 2 on that left and by a negative 2 on that right. So let's go ahead and do that. So, ooh, that's very thick. I'm separating that, and it says multiply by a positive 2. So we're going to multiply by a positive 2. On this side, it's a negative 2. So we're multiplying by a negative 2. Let's see what that equals. So negative 4 times 2 is going to be a negative 8. And then that is less than or equal to 6 times 2, which is a positive 12. Let's simplify that negative side. So negative 4 times negative 2 is going to be a positive 8. And then that should be less than or equal to 6 times negative 2. Well, a positive times a negative is a negative. 6 times 2 is 12. So our next question is the statement still true? I'm looking at this one over here. So is negative 8 less than or equal to 12? And yes, it is. So that statement is still true. Let's look at that second statement. So is 8 less than or equal to negative 12? No, that is not true, because this one's a negative and this one's a positive. A positive is always bigger than a negative. So that statement is not true. Let's try that with division. So maybe you saw a little bit of the difference between those. Maybe you're thinking in your head, oh, this is how I can make it true. So let's see if it holds true when we divide instead of multiply. So let's go in, we're separating, and I'm multiplying this left one by a positive 2, and I'm multiplying the left one, or the right one, by a negative 2, So let's simplify. Negative 8 times 2 is going to be a negative 16. And then 18 times 2 is going to give me a positive 36. And you can use your calculator for these. And then we're going to make sure we copy down that same exact sign. For that right one, we've got a negative 8 times a negative 2. Negative times a negative is positive. 8 times 2 is 16. And then on the right side, we have 18 times negative 2. Positive times a negative is a negative. 18 times 2 is 36. And then we'll copy down that same sign because we don't know any bit different. So now we're asking ourselves, is the statement still true? So on the left side, we have negative 16 is less than or equal to 36. Well, 36 is positive, negative 16 is obviously negative, and so a negative is always going to be smaller than a positive. So that one is still true. Let's look at the negative one on the right. 16 is less than or equal to negative 36. That is not true anymore. So if you notice between this one and the last one that we did, whenever we multiplied or divided by a negative number, it made the statement not true. So I want you to think to yourself, how could I make that statement true? Looking at these two, I know that this one is true and this one is not true. How do I make this one not true again? So here's the rule. Whenever we're multiplying or dividing inequalities by a negative number, so only a negative, we just tested that, it's only negative. We know that we're going to flip the sign to keep the statement equal. So flip the sign to keep the statement equal. We want it to be equivalent. In order to do that, we have to flip the sign. So what do I mean by that? Let's go back over here. So I know that this was a false statement. If I would have flipped the sign, so if I would have taken this and put it in the other direction. Hey, look, now it's a true statement. 16 is bigger than or equal to negative 36. So that is a super important part of our notes today. Whenever we're multiplying or dividing inequalities by a negative sign, we have to flip the sign to keep the statement equal. So make sure that's in your notes. So I've got some practice problems for us to try. I'm going to do one, and then I'm going to have you pause it. So let's look at that first one there. Just like before, draw your line, circle your variable. I see multiplication happening here, so I'm going to do division on both sides. I'm dividing by whatever number is with my x, because I have to get rid of it. So in this case, I'm dividing by a positive 5. Dividing by a positive 5. That makes that go away, and we're left with an x. Now we're taking negative 25 divided by 5, and that's going to equal a negative 5. Now the question is, do I keep the same sign, or do I flip it? I'm looking at the number that I divided by. So I divided by a positive 5. Remember, we only flip the sign if we multiply or divide by a negative number. So in this case, I would not flip my sign because I divided by a positive 5. And that's going to be my simplified inequality. To graph it, I know that it's going to be a closed circle right there because that's where my 5 is. I'm looking at one number smaller and one number bigger. And I'm going to plug both those in. I'm doing it quickly in my head just to save time. And I know that my arrow should be going in, let's see, this direction here, to the left. So I'm going to do one more with you. Sorry, I lied. I'm going to do this problem down here. So we're drawing our line. That is a very thick line. Drawing our line, circling our variable, and then I see multiplication happening here. So I'm going to go ahead and do division on both sides. I'm dividing by a negative 2. Divide by a negative 2. And then I'm going to be left with just my variable a after I do that. On that right side, I've got negative 9 divided by negative 2. 9 divided by 2 doesn't come out evenly, but I can either enter it in my calculator or just do it in my head because dividing by 2 is not super hard. It is a little hard though. So I know 9 divided by 2 equals 4.5, and a negative divided by a negative equals a positive. Now my question is, did I flip my sign? And this time I do flip my sign because I'm dividing by a negative 2. So that causes me to flip it. Now I'm going to go ahead and graph. I know that it's going to be an open circle because the inequality does not have a line underneath. So it is an open circle at 4.5. 0.5. That's a 5, I promise. I'm going to go lower. I'm going to go bigger. And then I'm plugging the number to the left and to the right into my original inequality. And again, to save time, I'm sorry, I'm skipping showing you this. If you need me to show you it though, ask me for help, or you can go back and look at me doing this in this video previously or an older video. So our inequality is going to go in that direction. So pause the video, try these two problems. If you do not like working with fractions, just take that fraction into your calculator and make it into a decimal. Go ahead and pause the video. And there's your two answers for those two problems. So go ahead and double check yourself, pause the video if you need to go through my work to see how I got these answers. So now the last thing left is going over homework. So you're going to be in your textbook today and you're going to be doing those homework problems. So if you have any questions, please send me an email or hop onto Zoom and ask me questions.